Good morning, my name is Fernanda Padron. I'm from Group 222. My roll number is 34, and I'm going to explain the problem number 2. It says, a 1.2 ton car moves 30 meters per second. What will be its kinetic energy? And if it speeds down until its velocity is halved, what will be the work done by the brakes? First, we need to know which is the data. In this case, it will be the 1.2 ton, the 30 meters per second, and we need to find the kinetic energy and the work. First, the formula for kinetic energy is mass times velocity squared divided by 2. To find the mass, we need to change the ton to kilograms. So we need to multiply by 1000 kilograms and divided by 1 ton. It equals to 1200 kilograms. So we just need to substitute in the formula, and it will be 1200 kilograms times 30 meters per second squared and divided by 2. The answer will be 540,000 joules. Then it says that the velocity is halved, so we just need to divide it by 2. So 30 meters per second divided by 2 equals to 15 meters per second. So we just need to change the velocity in the formula, and it will be 1200 kilograms times 15 meters per second squared divided by 2. It equals to 135,000 joules. Then it asks us to find the work, and the formula is final kinetic energy minus initial kinetic energy. So we just need to substitute with the data we have, and it will be 540,000 joules subtracted by 135,000 joules, and the work is 405,000 joules. Thanks for your attention.
Hello, my name is Edna Gabriela Garcia. I'm from Group 222, and my team is Team F. Today I'm going to explain how to solve problem 3 of the evidence stage 3. The statement says, how much power in HP is used to lift a 60 kilonewton load 33 meters from ground in 1.5 minutes? First of all, we need to identify our data. So we've got 60 kilonewtons, 33 meters, and 1.5 minutes. So we're gonna put here, we got the force that is equal to 60 kilonewtons. We got displacement that is equal to 33 meters. And we got time that is equal to 1.5 minutes. Okay, so we need to find a formula instead of solving this problem. So here the statement says how much power in HP is used to lift a 60 kilonewtons load from 32 meters, etc. So here they ask us for power. So the formula of power is equal to work over time. If we search in our data, we don't have work. So we need to, instead to find work, we're gonna put the formula of work. That work is equal to force times cosine of the angle times displacement. Okay, so now let's do the substitution. Let's start with the formula of work. So work is equals to force. That force we got 60 kilonewtons. So here we need the force needs to be in newtons. So if we want to change kilonewtons to newtons, we need to know that 1 kilonewton is equal to 1000 newtons. So we just multiply 60 times 1000. So we're gonna have 60,000 newtons. We put parentheses times cosine of the angle. Here we don't have an angle, or well, we have it, but the force is going up because you're lifting an object. So you put it up, and it, and the displacement is also up. So the angle will be 0. So here will be times cosine of 0 times displacement, that we also have, here we have displacement, so it will be times 33. Work would be equal to 1980 joules. Now that we have the work, we can substitute it on the formula of power. So power equals to work, that we have work here, over time, 1.5 minutes. Here we need to change it from minutes to seconds. So we just put 1.5 times 60. That will be equal to 90. Okay, we have this. So power will be equal to 22,000. But if we read again the statement, here says how much power in HP. So HP means horsepower. So 1 HP is equal to 746 watts. Okay? So if we want to convert this 22,000 watts to HP, what we're gonna do is just to divide. So we're gonna put 22,000 divided by 746. This will be equal to 29.49 HP. So our answer is this one. And with this, I've finished to explain this exercise, and that's it. Thank you.
Hi, my name is Camila, and I'm going to explain the problem number 4. And it says the work done to move a box from A to B point is 1060 joules. Calculate the force exerted on the box. Look at the figure below. So in this figure, it gives you the angle and the height of the distance. So what I did was to first write the data it gave us. So it's work it's equals to 1060. The angle is 60 grades and the distance is 1.5. Okay, the formula for work is force times cosine of the angle times the distance. So what I did was to just move it so I could divide the work times the other data, so I could get the force of the problem. So I did what I did was to divide um 1060 times the cosine of 60 times 1.5. So and it give us it give us uh, two, 2080, and that will be the answer. So if we convert it and we just use the normal formula, it will be force equals to 12,000 times cosine of 60 times the distance, that it will be 1.5. It give us 1060, and that will be the answer.
Hi, my name is Enia Carolina Maguer Flores. I'm from group 222. I'm from team 5, and I'm going to make a problem 5 and letter 8. So here says that we need to find like the mechanical energy. And we know that mechanical energy is potential energy times kinetic. And it says that we have like the height, that's 35 meters, and we know that the only one that has the height in the formula is potential. So potential energy is equal to mass times gravity times height, and this is equal to mass that it says it's 600 kilograms times 9.8 times 35. Okay, it's meter per second square times 35 meters. And getting this, we get that it's 600 times 9.8, and that times 35 times. And we get that its potential energy is equal to 205 million 205 and what 800 800 800 joules. And it says that here a kinetic, and the kinetic formula that we need velocity, but like it here says that it's 0 because it's just standing there, it doesn't have a displacement. So kinetic energy will be equal to 0, and mechanical energy will be equal to the same. So mechanical energy is equal to 205,800 joules. Thanks you.
Okay, so I'm Romina and I'm going to explain problem number 5. That is, a couple get up in a wagon of a roller coaster. The total mass is about 600 kilograms. If the wagon's velocity at point A is 0, find the height at point C and velocity at point B. Okay, so the height C is 18.46 meters, and velocity D is 26.19 meters per second. So The problem that I made was multiply 600 with 18 exponent 2 divided by 2. So that gave me 97,200,000 J. So like here I don't have the problem A, but well, it resulted 205,800,000. So we are going to rest that. Yeah. Okay. No, that's not how you pronounce it, but well, you quite understand me. So that gives us the result of 108,600,000. So we divide U between mg, and that gave us 18.46. That's the high C. And for velocity V, the result of problem A was, like I said before, 205,800,000 J. So we divide that between M. So we divide 2. No. We multiply 2 with 205,800,000 and with 600 that is divided, like you can see on the screen, and that gave us 26.19 meters per second. So that's how I did that. I did those problems. I don't know if you quite understand me, but that is the procedure, and I'm not really good at explaining, but that's how I did it. So thank you.